when we talk about topology and generative, I want to give you guys a high-level understanding of really what it is. Inside Discovery, it was in ago, now it's currently out of beta. So we'll talk about not only what you can do with it, but how to use Discovery and Topology Optimization. I want to make this experience quick tips and training so you can get away, hit the ground running, and try this product out. Another key thing, the definition of interactive topology optimization. As I go through a couple different examples, more than happy to share them with you if you guys want to try different things out, as well as I'll have my contact information at the very end. Feel free to contact me. More than happy to work with you guys. I don't care if you are in the Galapagos Islands trying to do something, or whether you're in Europe. I'm here to help you out, make you successful with the product. But not only that, hear your feedback. We're always trying to improve and make the product better as we go through. We talked about getting started with topology optimization, which is always key. And then two, what do you do with it? Because at the end of the day, you can take the content, and it's great to see this kind of organic shape, but then what do you do with it, right? Let's talk about manufacturing processes. Let's talk about how do you leverage this data. The upcoming webinars, something to keep. I'm going to be doing another one in less than a month called around CFD. So if you're interested in fluids, not only is it just for fluids, but there's other areas we can use CFD for. That's also a part of Discovery. Something to look into, so mark that on a calendar. For all the people that are out in EMEA or Europe and are going to be actually at the additive manufacturing show called Formnext. This is the largest additive manufacturing show I think, in the world. So I'll be out there. It'll be great. If you're there too, please stop by the booth, say hello, and we can have a conversation. And then the other webinar we'll be hosting is around rapid design exploration, leveraging some of the design side of Discovery and showing how we can quickly iterate to minimize a lot of prototyping. If you're looking after this discussion, if you're looking to try the product out, please take a look at our Discovery forum. We have a lot of engagement there. We have our whole technical team on there engaging, answering questions, assisting. We have everything from tutorials to, we started a new series called the 2-Minute Quick Tips. If you want to learn some quick content and just know how to use the product, as well as our support there. And as you can see on the very far right, you can get a free trial right there and go through it. So you're hearing the term Discovery, and what does that really mean, right? And what is around Discovery? What do the products include? And we have a design phase, which is that back engine of Discovery space claim. That's where you're going to be able to do some rapid concept modeling. You can do parts assemblies and drawings. You can bring in plenty of files and edit them, iterate with them. So not only is it a CAD package, but it allows you to quickly create sheet parts and so forth. We're going to really dive more into the Discovery Live section of Discovery. This is where I like to call it the interactive or instantaneous simulation. As we go through today, we're going to specifically focus on topology optimization or generative design and see how simulation plays a role in that process. And then we have the third piece, which is the analyze, right? Is you're going to hear me talk about, do you want to iterate quickly or do you want more accuracy, right? And there's a trade-off for each one, but the goal here today is to say, hey, look, I want to get 80% of the way there, right? I want to know what direction I'm going in as a designer or a CAD guy and see, okay, well, now I'm going in the right direction. Now I can maybe hand off to somebody else who might have a little bit more experience and go through that analyze phase, right? So the focus today is quickly iterating, quickly seeing if I'm going down that right path, because as a designer, you have the tendency of sometimes over designing, right? And when you talk about manufacturing processes, well, how do we now think about not over designing the parts and then saving costs in manufacturing as well? I know we started a couple minutes late, but just to give you a little bit of background, I've been in the industry for quite some time. I don't like to categorize it as years because I feel older when I go with years. But I started my career in the defense industry and then the biomedical industry. So I was an electrical mechanical engineer, spent a lot of time designing boxes and enclosures for aircrafts. And in that process, understanding simulation, looking at what we have today with Discovery, it's remarkable to see how quickly we can go through and iterate, how quickly I can get a result and then move forward rather than having to wait a couple hours or even 30 or 40 minutes, right? I can quickly get an idea and move forward and keep that momentum going as well. So the big question today is, well, what is topology optimization and what is generative design, right? And if you go to Wikipedia, you got these in-depth big words about what these two products is. And the funny thing is that they're really the same technology, right? One, topology optimization, a part of generative design, you are quickly iterating, right? So the goal today is not to sit here and contemplate, okay, well, it does this versus this. It's going to generate the most optimal part based on the load constraints, right? So right away, when I saw these explanations, this is what I thought, right? If you guys know Family Guy, famous Stewie, right? What does this all really mean? Instead of really talking about the analytics, I'll show you today. I want to show you how easy it is to use our products and dive through these things. But what's even better is talking about a customer example, right? We have plenty of customer examples of how people are leveraging our products today, but specifically topology optimization. One of our partners, CADFEM, their customer Smile, they actually created a hydraulic oil manifold. And what they did is they took this manifold, very prismatic, right? It's a rectangle and it's basically drilled, right? Like all the inlets and outlets are just drilled. So how do we reduce weight? How do we reduce all the height, but still keep that range of the pressure drop, right? So they went through this entire exercise, leveraging discovery, and we came out with a pretty impressive part at the very end. So it's always good to see that and understand how somebody's actually using it. And if customer interested in trying it out and have questions, please reach out. So let's dive into the product. Let's talk about some things. And this is one of my favorite examples, right? If you guys know me or follow me on LinkedIn, this is actually a great simple bracket, right? People look at it as just, oh, well, it's too simple at the end of the day, but really it's not. Everybody has access to this. I'm going to walk you through on how to use it. I have about 5 or 6 examples here. So please, bear with me, but I think we're going to have some good conversations, and please ask questions. I want to save some time to the end, a lot of time, and just address some of the questions we have here. So your first experience with discovery, what you're going to see is this nice welcome window, right? It's uncluttered. It's very simple. We give you examples, and the bracket is one of my favorite examples to start with. But you can also start with the topology optimization and bring in your own example. But just to get some familiarity, start with the bracket optimization. Now, right away, you're going to see some pink and purple, right? I want to start off by, instead of diving right into topology, I'll walk you through all these different things. But let's just talk about design and simulation, right? And as a designer, being a designer for quite some time, simulation is always that scary word, like, I got to have a PhD to do this, or, ooh, I don't know what's really max stress or deformation, or what's von Mises really mean? And it's actually really simple, right? So for example, as you can see, I have some forces which are set up. Each one it's about, 400 newtons on each one of these. And I'm basically putting up on bracket. Well, if you look at my fixed support, think about it as if I bolted it down in this area. Now, the nice thing is if I go ahead and just hit play, right, what I'm seeing here is right off the bat, the von Mises stresses, meaning this is the area where you're going to see stress when I pull up on using or I set 400 newtons here, right? Well, my other favorite part is, well, yeah, but what's the deformation look like? What happens if I'm actually doing this right now? This is an exaggerated scale, but you're going to get an idea of like, hey, if I pull up, this is what's going to happen to the part. So when we actually do topology optimization, we're accounting for these things. We're accounting for the stresses here as we create it. So for example, under topology optimization, it's by default disabled, right? So what you always want to do is click on there, hit enabled. If you don't have topology optimization, we'll talk about how to access that in my next example. But what you'll see here as we open it up, fairly simple, right? We're not making this complicated. There's not 20 menus you have to go through. We want to keep it simple. What's the percent reduction type? Well, it's a percentage. How much do I want to reduce it by? 55%, or I can change it to 10% or whatever that number wants to be. And then inflation. Well, what inflation means, if I go ahead and change this, let's make this fit. What you'll see this is telling me this is my keep out zone based off where stresses are at the top, right? At 4 bolts, and then where the forces are happening, these are my keep out areas, right? So don't get rid of them for me. Optimize everything else, right? And what we have the ability to do is now keep it actually simple, right? There's not a lot to go with. There's no other constraints I need to add because I have my forces and support. So all I'm going to do is now hit play. Now we're going to talk about this bottom menu here. What this is actually showing, and this is all real time right now, is we're going through, and I actually have a time in my other example. This shows how quickly we're going to iterate. We have these kind of calculators on the far right, and it's a graph showing me where I'm going to converge to, right? As I get down to 0, it's going to continue and flatten out. And this little play button that you see blinking is now going to stop, right? That means it's converged, right? This is the best we can get to, you know? So people might look at this and be like, well, you know, it's kind of oatmeal-y looking, right? Very clumpy and so forth. Coming back to the point I mentioned earlier, am I looking for, I want to iterate really quickly, or do I want high fidelity, high accuracy at the moment? And I have my settings set to speed. I want to quickly get an idea of what's going on here, see where the stresses are, see what I'm getting out of it, and then think about a design change if I need to do a design change. So if you look at this, where do you see the stresses right now? Well, specifically right here, right? And then two, you have it on all 4 corners. Well, let's say my design constraints change. Well, instead of both in 4 areas, how about it's 3 areas? This is the beauty about discovery. It's really an exploration tool, right? So when we talked about that wheel of the different phases, design, explore, analyze, from a design standpoint, we're leveraging the technology of space claim here. And I can say, well, I know there's stress here. I'm going to use the pull command and just pull and make this fillet larger, because knowing as an engineer that if I add more of a fillet, it's the stress relief. And now I'm instantaneously seeing that update, right? There wasn't no rebuild. There wasn't let me go push it off and run it again. I'm now instantaneously seeing that update. Now the area to think about too is as I mentioned, what happens if we change some of these brackets, right? I'm not going to mount at 4 areas. I'm just going to come in and delete using the delete. And then I'm going to move just this whole, and let's say we move it over to center it a little bit more. I'm now editing in real time, and I'm getting instantaneous results. This is that bullet point I mentioned on the agenda of interactive topology optimization. What if I did this? Or what if I did that? What type of result am I going to get, right? Or what if my designer came back or my engineer and said, hey, you know what, per the design requirements, we need a cutout here. And, you know, how we're going to like stick the bolt through or run the cables through for this example. Okay, well, great. Well, how is this model going to look now? So if I came in, as you can see, we have all the functionality that you see as the traditional CAD modeler. Well, I'm going to go and create a rectangle. Let's go ahead and create a angle here. I'm going to pick this face. Let's create go right on this face, and let's say we're going to create a cutout that comes maybe like this, right? Just as an example. There's a pull, and then come through and just cut this guy out. I'm exploring. I'm going through this iteration process, and now it's going back and updated for me, right? I don't have to wait a long time. And you look at how long this is taking here. It's been about now we're on 7 seconds, 8 seconds. I'm now getting to this point. I'm getting to this idea of like, hey, you know what? I like what I have. Well, now what do I do with this, right? And I'm going to show you some ways of what we can do with this. Let's say if I want to go 3D print this, how do I get an STL file? Or, hey, I want a CAD-ready model, maybe like a B-rep surface. How do I do that, right? So I'm going to let this iterate a little bit more, and then we're going to kick this off as the STL file. When we talk about STL files, there's 2 ways we can do this. One, if you look at the oatmeal-y looking piece here, I can kick it out just like that, right? With those. But the cool thing is that we came out with this smoothing function within our software to say, hey, looking at a deviation, at the values here, let's get a really clean surface here, and then use that as we want to go to manufacturing. So I'm going to go ahead and just pause this now. And under where it says convert results, I mentioned the first one is going to be out this piece right here, exactly how it is. Or let's leverage our smoothing technology coming through and now give me a STL file out of it. So as you can see, I'm not hitting any hotkeys here, or there's nothing special about it. I'm not opening up another file. This is all done instantaneously here. And you can see it's actually very impressive, right? I'm going to go ahead and just hide the existing topology piece. And oops, that's actually the piece I wanted. Let's go and turn off the actual solid, right? And we can just turn off the colors. So this main one which says show results, we're turning that off. And now you can see how smooth this is, right? Well, great. We have the STL, but any way we can validate everything we did on this STL file? Because we've gone through a conversion rate, and the answer is yes, right? Is everything is just within this menu. Under convert results, you can drop down and you have that topology optimization result. If I right click, I can say, hey, validation solution. And what this does is it takes all your force, all your fixed supports, makes a copy right here and applies it. And now I can actually go back through and run a quick validation study. Hey, look, you know what? Hey, the stresses have dropped. This is fantastic. Or let me take a look at the deformation here on this STL file that I just did, right? Great, it's looking good. The stresses have dropped. I have this deformation. Those values have dropped as well. This looks great now. Right? Now I can save as and post it out and go 3D print it, or drop it on a Haas UMC 750 and go machine this guy, right? Speaking of manufacturing, I'm sure a question that's going to be popping in is, well, do we count for manufacturing processes? And that's definitely on our roadmap. We know that there's plenty of manufacturing processes out there, whether it's 3-axis or 5-axis or 3D printing or metal, and we have all the technology. We're working on it, but that's definitely in our plan at the end of the day. So with that said, let's go ahead and move forward in another example, right? I'm going to close this guy out. We won't save it. And you have access once again right here in our first window. If you ever accidentally close it out under File, Start Page, boom, here it is. If you want to do some CFD or some thermal, we have examples for you to dive into, right? Let's go ahead and grab another example. All right. So this is actually one of my favorites because we're going to start thinking about the different load cases, right? And if you notice in the other example, all we had was just one load, right? So if we look at this, now we're actually starting from scratch. How do I even access topology optimization? And let's go through the situation of saying, hey, we have 3 different load cases. Give me now the optimum design based off 3 different load cases, right? Because technically, you're never just going to be pulling down a direction, right? So to start off, we have create solution. And today, topology optimization is available in structural behavior. And this is where I'm going to pick my materials. I'll go with aluminum and just say create. I'm just going to kick this off. Now, what we're working on for the next version is incorporating modal analysis, right? So you can do a structural and a modal and combine those two to then give you the optimum design, right? So think about a bridge, or think about a standoff on a box. It's not only going to have a structural portion, but another key thing in today engineering is modal. So imagine combining these two and getting a topology optimization result based off these 2 types of physics, right? So once we have our structural, we can go through and set up forces. So let's say under setup, very easy here. We're going to say we're going to have, let's do a support, fixed support here. If I hold down control, like any other traditional CAD package, these are my 2 fixed supports. Fantastic. Where's my force going to come from? Under setup, force. You guys can see this is not rocket science, right? We have the forces, we have the mass, we have the supports, we have the moments, pressure, everything you can do right here off the bat. And this is where my force is going to be, for example, right? So let's go with maybe 1,000 newtons, right? Key that in. And if I click on like the head of the arrow, flips the direction if you want that. And now we have this, right? So if I go ahead and hit play, what we're looking at right away is we're just looking at stress, right? Okay, well, getting some feedback instantaneously. What's kind of the deformation going on? Let's look at what's going on there. Okay, that makes sense. The force and the stresses. Okay, we're getting somewhere here, right? But let's now do topology optimization. So under add, drop down, turn on topology optimization, and it's enabled, right? You can see the inflation rate is a little bit high. I'm going to go with like 2 millimeters for now, and we'll go with that. And then now I can just hit play and start thinking and start seeing exactly what is happening, what type of feedback I'm getting, and then move forward, right? Another example too is right above the play. This is where we can change the fidelity, right? Or, I mean, iterating, quick, speed, getting an idea, or accuracy, move up the fidelity here. And this is where we're going to start seeing it quick through. Now you can see at the very far right, I have the topology result volume. I'm actually, this is what we're seeing to know, like, hey, are we getting close to result? What are we getting here? How does this need to look? This is starting to kind of look like like a motorcycle swing arm in some type of fashion, right? But the forces are not going to be just at that one location. So let's talk about adding additional forces, right? That's what it's about when you start diving in here. So what we have that's still in beta today, that will be coming out of beta in our next release, is our load case. If you ever want to get to these options under File, Live Options, you're going to see under our advanced area, just turn on Enable Beta Features. This is how you can access all of our cool beta functionality that's coming out, and then always give us feedback in that round too. So what do? Well, I'm going to come down, say case. I'm going to add a load case. Now it's saying load case 2. What does this need to be? So honestly, instead of 1,000, I'm going to edit this guy here and say, hey, look, I'm going to this is going in that direction. How about if we did a force coming down in that direction, right? And we could flip it, doesn't really matter, right? And let's make this 2,500. That's going to be that force right there, okay? Well, where else would we see kind of a different force, right? I'm going to come back, another load case 3, right? Let's come in here, let's edit this one, that's 2,500, edit, and then I'm going to, the hotkey to kind of move this around is Alt, so kind of pick up faces, edges to change the direction. So I'm just going to say maybe a force is coming in that kind of angle direction, right? And maybe let's make this one now 1,500. Now we're going to have a new load case right there. So now that one's 1,500. So you can see the load cases. If I want to look at all the different cases in example, I'm going to load case, and this is where I can change it. Go back to load case 1, 3, or edit load cases, and it actually brings up this really nice table here, right? And I can even add and remove, so I can just fire through, if I have an Excel spreadsheet, bring that sucker in and have all these different setups based off that location right there, right? So simple, it's not rocket science. But the cool thing is we want to hit play, it's now going to iterate and run each one of these load cases, combine them together, right? Giving me the optimum design based off the 3 cases that we've done here, right? So as you go through, you see it's kind of like a lightning storm looking thing, right? Like it's blue, and all of a sudden it turns, and it's going to iterate through this whole process and start giving me that design that I'm looking for. So, the goal here, what I'm trying to show you is, not only can we just do it based off one, right, to quickly get an idea, but as we start knowing about our design constraints, as we start understanding, okay, well, wait a second, we're going to have forces in all these different areas, you can see how quickly we can do this. All this is real time. I'm not hiding anything. I'm getting an idea of what's going on here. And the nice thing about this is I can just hit stop, go back, make a change, add a cut, do this. Have these what if scenarios of what if I did change this design, right? It's a great way to go through this process and just understand, am I going on the right track, right? Now imagine if you're working analyst at work, imagine now instead of going to that analyst, look, because that guy's probably is backed up. Here's 10 designs, tell me which one is kind of better. You can actually quickly iterate, get an idea, and present now 2 or 3 designs. Say, hey, look, I'm there now. I got you 80% of the way there. Help me with your expertise to get me to that next 20%, right? And what design is going to be better. So think about this as upfront simulation, right? Upfront doing topology optimization at the beginning of this design phase right here. So I'm just going to stop this so we can move on to example and address some questions as well. So close this guy out. Save that. Let's go ahead and take a look at, I got I love this example, right? I'm a CAD CAM guy by trade, manufacturing. I love CNC machining. I'm a proud owner of a CNC machine, a Tormach, and I just love tinkering. Like a lot of people on this call who are engineers, you love to, right? And I'm sure a lot of us have something like in our garage, right? We have a clamp of some sort. And the cool thing is that, well, how do I start thinking about what if I'm getting a result and I need to make some changes? How do we quickly make these design changes through this process? So for example, just to set up the story for you guys, we have fixed support, we have some pressure, depending on how the clamp is. We go through and kind of create something I like to call configurations, really parameter studies, set up different types of scenarios, say, hey, change these different parameters based off this, and then now go run the analysis, right? So we can do all of these things. So lots of questions, love it. We're gonna address that. I have 2 more examples, and we'll dive through all this stuff too. Pressure, simple, mass. I'm gonna turn on Topology. Let's first, as I said, I like to get some feedback right away, right? How are things gonna look just from a simulation standpoint, right? There's not a lot of pressure here. How's deformation gonna look? That makes sense, right? But how can I optimize this at the end of the day, right? So I'm gonna go ahead and turn on the topology optimization. Once again, enable, very bottom, that will turn on. I'm gonna ingrain that in your head, right? This is how easy it is to access this stuff. Now, as you see, once again, for people that are joining, I still see people joining in. The pink means that these are my keep out regions. Do not get rid of this because I'm gonna have to put some bolts here, do something there, right? And let's go ahead and hit play. Let's see what kind of feedback I'm getting here. Now, as we go through this iterative, right, you're gonna know a couple of things, right? And maybe you guys can call that, put it in the chat, but as it's iterating, what's the biggest flaw? And this is what happens as a designer. There's so many times I've gone through and you just quickly get ideas out and you're like, wait a second, this is not going to work because of this situation, right? Or wait a second, look right here. Look at how all is coming together. It's not accounting for the slots, right? Set up my problem kind of, right? Like this is not wrong if I just want like a dummy part, right? That's not going to work, but I need to account for all these different things here. So instead of waiting time to know, you know what, I forgot to put that extra fixed support, I got to go redo this all again. I know we've all been in that situation. I did that plenty of times back in my days of, I'll come back in 2 hours and see where I'm at. And I just forgot to put that one fixed support that's going to affect the entire process here, right? So this is just something to kind of keep in mind is if you start seeing an issue, we're going to stop this guy. I'm going to come back. And what was the issue, right? So if we look at the regions here, right, the masses, what I can do is kind of create a kind of a region of like a keep out, another keep out region that I don't want it to be inflated too much, but in general under setup, we can go under mass and I'm gonna say, well, where's the mass gonna be? Maybe right here. I'll hold down control, pick this up here and apply just a small amount of mass, right? Because that's gonna be moving around. We'll have that. And then now when we go back through and run the topology optimization, now you're gonna see exactly it's gonna keep the area out. Now I'm gonna come back in, let's move the speed down because I want this sucker just to fly through and give me some quick results here, right? So here we are, quickly iterating. And you notice just with that small little change, how quickly my result is happening, right? So think about if you move that slider all the way up to get more accuracy, you're gonna get a lot more detail here on everything, right? And then of course we can take this, save it as an STL file, convert it over to a CAD model, BREP surface, and then go drop another cut in it or give it to somebody else to do some work with it, right? So this is a great phase and we're iterating through this entire process just to see what's going on. You see here, the whole point here was to not have, we wanted the slot. So now we have that incorporated and come back and make some additional changes and so forth. The idea here, quick iteration, get an idea, and then we can move forward from a prototyping phase. Let's dive into another quick example here too. I want to set on, and I know we're coming up on time here. open up to some questions is I think a lot of people know, as an engineer, you've heard of like the challenge, the COA bracket. You've probably seen something like this, right? So the beautiful thing about topology optimization, generative design, is the immediate feedback, right? That's with discovery. Immediate feedback of all these fixtures. Do I need all these bolts based off of the force I'm putting here, right? Now the example is, and I already showed you guys how to set up multiple load cases, right? But let's say, for example, once again, we'll do a structural analysis. This body will be aluminum. Fantastic. Quickly go through. There we go. Quickly go through. Let's add a topology optimization here. What are we doing? Let's add a support. Support's going to be, bolts are going to go here. So let's just rotate this guy around. If you got a face mount, this is like, can't live without this guy now, but big fan of them. We'll select those. That's where the bolts go. But then two, consider these top faces too, right? That's where the bolt's going to have some contact there. So I am just going to these two, my entire process. You see, there's not a lot of selection, right? I have the support. Where's my load going to be now? Just come back under setup, add a force. We'll just put load in that area, and let's just go with up this up a little bit. Let's go with 2,000 newton, whatever for kicks, right? Let's get some feedback. Let's see what's going on. You can see my inflation is right here. Maybe change that to 2. Looks a little bit cleaner. Keep out areas, and then what I can do now is I'm going to disable this guy, just so we can see from kind of a simulation standpoint where stress is happening. Great, makes sense, right? The stresses are happening there. What does the deformation look like? Totally makes, right? Now, knowing what's going on, let's go through, just re-enable this topology optimization and give me a result. Let's see what is happening here, right? Now, in this example, of course, we would go to set up multiple load cases, but what I find interesting is sometimes people see what comes out of generative, and it gives you something where you're like, well, wait a second, as an engineer, I would have just expected to have all these different areas bolted down, right? Now I'm going to just go ahead and drop this speed so you can just see how quickly this guy's going to go, just for time's sake. But once again, looking at this and saying, hey, look, here we see it's removing that material. Why is that? Why is it doing that? Is it going to keep the 2 front bolts? But from a design standpoint, you need those, because that gets bolted to something else to hold something else down, right? And we've always been in that situation where we need something. Well, based off this design criteria, yeah, you don't need it. But let's say if I start adding multiple load, one going in a vertical area, one going at a 45-degree area, then it will start accounting for those back bolts because I've now added more load cases to it, right? So something to keep in mind here is that the beautiful part about generative, it's really going to open your eyes to not even based off criteria, or hey, is what I'm assuming even correct? I need to go back and think about this and iterate through different ideas, right? But you have an idea within 10, 15 seconds. I see what's going on here. I can come back in, add another load, and go from there. Due to time, I would go through and add some more loads, but I've already showcased that. The last piece I do want to talk about is even from a manual standpoint, and this is from one of our partners, MCAM Northwest, phenomenal partners of ours. They actually did a additive manufacturing webinar leveraging discovery for manufacturing, right? What they did is said, hey, well, I have this fixture that will mount, right? I have multiple pieces, multiple machine parts, and all I'm doing is using this for drilling, right? This is all I have here, right? This is the part that I'm drilling, so I'm just drop it in, drill, new part in, done, right? Well, what's the cost? If I had to go make this, on a CNC machine, how much would this cost me, right? And that starts adding up. Or you think about the time, right? Or who some people might not even have the right equipment and the right tooling to do that. What if they decided to do some type of additive manufacturing? How about if I said, let me combine all the individual pieces, let's 3D print this out and have it all as one piece and make it light? Because coming from manufacturing, and there's some manufacturing people on here, we all know how heavy a vise is, right? You try to get a vise off a machine or move it from a table, think about injury, think about weight, think about hurting yourself. All those things come into play when you're working with heavy equipment like that. So what we did is, I think I have this side over here. What I did was we took it, and they have a webinar, definitely check it out. He really goes through the entire manufacturing process of it. But we took and we said, well, let's take all these pieces that are bolted together that really could be combined as one part, and then put it all together, right? So let me go ahead and open up this guy here. Let's do grab so many parts here. Go back. I'm going to try this guy. There it is. So what you can see is we've actually taken a lot of these individual components and combined it into that base plate. And I have another instance open so you guys can kind of see how that looks, right? We took these pieces, combined them to the base plate, because we want to 3D print it, right? Now what you can see here too is have some forces, and these can all change. Now, ideally, I would do them as multiple load cases, right? Just in case something tweaks a different way, or I'm putting in a different force in another way. But from an avenue of what it's given me, even from fixed supports, here are all my fixed supports. I'm just assuming on this area, this is where it's going to be kind of bolted down to like a base plate if I wanted to, or onto a table or clamp down, or however that's going to set up. But if I run it, coming back to that Alcoa bracket example, do I really need all these fixed areas based off the loads I'm giving it, right? So that's important to think about. We're just going to run through this real quick, and you're going to see how all this. And I always forget to drop it down. You see, I have fidelity all the way up here, right? So I'm just going to drop this guy down all the way down, and then we're going to run this guy to see it real time, and just an idea here. So get an idea of how this fixture would look. 3D print it, right? Reduce the weight, optimize it, so I can have one of my guys on the shop floor drill these. It's easy. It's very easy to move around, and you can see that I don't need that other fixed support in that area, right? Based off the load conditions that I have here. So this example that MCAM Northwest gave of leveraging topology optimization for manufacturing from a fixture app is great, right? Is this ideal? I could probably delete some of this stuff. You even look at some of the funkiness that's going on here, right? Does make sense. Maybe I can add some more bolt holes to bolt this down to, and then this whole design will change. But the point here is to quickly iterate, get an idea of what's going on, maybe make a quick design change, and then now see this entire process. So with that said, I want to wrap things up, address some of the questions here. Once again, for people that have joined a little later, just some heads up is please visit our forum. We have this great community out there. This is where you can get a trial. You can find a lot of learning material. I have my contact information there, kurt.chan@ansys.com. Please reach out. You have any questions, I'm here to help, right? I'm not just doing this and then you're going to talk to me again. I want to engage with you guys. I saw a lot of people on here, a lot of familiar faces, a lot of familiar customers. Please reach out and help out. And just, I'm here to help. Lastly, too, the coming webinars. We have another webinar coming up. I'm going to be partnering up with one of our other technical managers. So around CFD. And if you're going to be at the biggest additive manufacturing show in Germany, Formnext, please stop by, and I'll be there the entire week. Our entire discovery team, our EMEA discovery team. And then one of my favorite webinars are coming up that we'll be doing as well is, I'll be a part of that, is the rapid design exploration, showing more of the design side of how you can quickly iterate and to get to prototyping, even minimize. That said,